This is the first video under the series Insulin and Diabetes Mellitus. Through this video, we will know how is insulin synthesized and how it is secreted from the beta cells. The pancreas gland has exocrine acinine and endocrine islet. Insulin is secreted by the beta cell of pancreas situated at the center of islet. Alpha cells at the periphery secrete glucagon, delta cells secrete somatostatin, and the F cells secrete pancreatic polypeptide. Now let's look at how beta cells synthesize insulin. Insulin is a peptide hormone. So basically, insulin synthesis is a protein synthesis process. The short arm of 11th chromosome in the nucleus of beta cells codes for the INS gene or the insulin gene. This gene is transcripted to form an mRNA sequence which gets translated to a signal sequence, and eventually upon addition of new sequences in the rough endoplasmic reticulum, pre-proinsulin is formed. This pre-proinsulin consists of the signal sequence, the A chain, B chain, and the C chain. A and B are held by 3 disulfide linkages. The signal sequence is clipped off to form a proinsulin. So the proinsulin has A, B and C chain. So in the Golgi, this insulin is packaged in a secretory vesicle where C-peptide is clipped off and insulin is formed and is stored within the vesicle. So what causes insulin release? When we take food, all nutrients in blood gets increased. Basically it is the increased glucose that triggers the insulin release. Glucose enters inside the beta cells through GLUT2 receptor. Remember, beta cells like GLUT2. So the GLUT2 receptor is present in beta cells, the liver, the intestinal cells, and the kidney. GLUT2 transport is a two-way transport. So to prevent the transport out from the cell, it is phosphorylated by glucokinase, glucose 6-phosphate, which undergoes oxidation to form ATP. ATP-sensitive potassium channel is always present in beta cells, which transfers potassium out of the cells. So this ATP closes the potassium channel and causes the increase in potassium ions inside the cell and cause the cell to be depolarized. This depolarization causes opening of voltage-gated calcium channel and causes calcium influx. This calcium causes the release of insulin-filled secretory vesicles out from the cells. This insulin secretion is biphasic, meaning it occurs in two phases. Within first few minutes of elevated blood glucose, plasma insulin increases up to 10-fold due to dumping of preformed insulin. This high insulin level decreases in about 5 to 10 minutes and again reaches a new plateau in 2 to 3 hours, which results from additional release of preformed insulin as well as release of new insulin. So what causes insulin secretion? Increased blood glucose, amino acids, fatty acids, incretins, glucagon, growth hormone, cortisol, the parasympathetic stimulation, and the beta-adrenergic stimulation all increase the insulin secretion. So what are incretins? They are the hormones secreted by the intestinal cells. Glucagon-like peptide GLP-1 and glucose-dependent insulinotropic peptide GIP, also known as gastric inhibitory peptide, are two notable incretins. They increase the insulin secretion, they decrease the glucagon secretion, they delay gastric emptying and promote satiety. These incretins are degraded in the body by endogenous dipeptidyl peptidases DPP4. So there are drugs acting on this incretin mechanism. The GLP agonists like exenatide mimic the GLP action. DPP4 antagonists like sitagliptin delay the endogenous degradation of incretins and enhance their level in blood. factors which decrease plasma insulin level are decreased blood glucose, fasting, or fat energy stimulation in somatostatin. A lot more to learn about insulin, right? For now, just remember it as the hormone of abundance. Thanks for watching.